Hello, my name is Paul Gray. As part of my bachelor's degree project, I had to manufacture certain components on a CNC machine. So I'd like to introduce you to the software program AlphaCam, which you use to transfer your designs to manufacturing on the CNC machine. AlphaCam is a software program that you can design complex parts, very much so like AutoCAD and any other design software. You can then take your design part, which my design part is a Geneva wheel, and the design here, as you can see, is outlined here. So what you have to do is create tool paths around the object. In essence, you're going to tell the machine where to cut, how deep to cut, and how fast to cut. Once you've created all your tool paths, you can set in the type of cutter you're going to use, speeds, feeds, lubricants, and so forth. So then what you can do is, when you have actually designed your part, set in all your dimensions and feeds and speeds, you can simulate it in AlphaCam before you actually physically go to the machine. What I'm going to do now is just run a solid simulation of the Geneva wheel being cut. This is a representation of the tool that will be in the CNC machine, cutting into the material, and will cut the shape. It will go through many iterations of the same program, stepping down each level as you program it. This enables you to see if what you've actually designed will come out as is in the CNC machine, to give you a preview. This is an important step, as planning is a massive part of manufacturing any component, that you must check everything and check everything again before you actually commit to using resources in the machine itself. So now it's gone through its full iteration and cut. You can see there that the machine now has cut out the shape of the Geneva wheel. Once you're happy that your program is running the way you want it to and everything is fine, you'll transfer from the PC through a serial cable into the CNC machine itself. Once it's been transferred in, the next step, you don't just go straight to manufacture. You'll actually retest again in simulation on the machine to make sure what went from here to here is the same. So you actually run a simulation on the machine. And that just shows you the path that the tool will take in the actual CNC machine itself. The CNC machine has a console here, which is the user interface. It has the stock, which has an x-axis. The stock actually will only travel up and down in the z-axis. All the movement for the part will be on the bed. The material will sit on the bed. The bed can move in the x and the y-axis, while the head will move in the z-axis. And this gives you 3 degrees of freedom to rotate and make complex shapes. As you can see here, by simple hand control I can move the bed in the y-axis. I can move in the x-axis. If I select the Z, I can bring the head up and I can bring the head down. So when you want to actually machine a part, you must set up a reference jig. This is a part that's perfectly level, and it has retainers which will hold your piece of material in place to allow the cut to be done smoothly. It must be secure. The next stage then is you must select your program. So you come to program management. And here's a list of other programs that are actually stored in the processor in the CNC machine. So I would simply come to the one that I want, that I know that I've called, and select it. This will then bring up what we call G-code. This is the actual machine language that has travelled, that you program in AlphaCam over here, and it gives X, Y and Z coordinates and other instructions as in where to travel to and traverse in each movement. The code will read at least 20 steps ahead of each cut so that it's a smooth, continuous movement. This code then you can check each line down through for the whole code. For simple pieces, code can actually be up to maybe 1,000 lines of code. For more complex, you can go into many thousands of lines of code. Once that's all been done, inside here is a carousel which holds all the tools. They remain there and they be called at any time in each step of the process.